In the previous podcast, we introduced the concept of urban tree canopy, the layer of leaves and branches that covers a portion of the city when viewed from above. But measuring canopy across an entire city is not as simple as counting trees. Cities often cover hundreds or even thousands of acres. Manually measuring every tree would take an enormous amount of time and effort. Instead, urban foresters rely on modern technology to measure canopy accurately and efficiently. One of the most common methods is aerial imagery. High-resolution photographs taken from airplanes or satellites allow urban foresters to see the city from above. These images clearly show tree crowns, buildings, roads, and other land features. Using specialized software, analysts can identify the areas covered by tree canopy and calculate the percentage of land shaded by trees. Another increasingly important technology is LiDAR, which stands for Light Detection and Ranging. LiDAR systems use lasers mounted on aircraft to scan the landscape below. The system sends thousands of laser pulses toward the ground and measures how long it takes for the light to bounce back. These measurements allow computers to create detailed three-dimensional maps of the environment. With LiDAR data, urban foresters can identify tree height, canopy shape, and even the structure of vegetation layers. This information can be extremely useful for understanding the complexity of the urban forest. Once aerial imagery or LiDAR data has been collected, the information is analyzed using Geographic Information Systems, commonly called GIS. GIS software allows urban foresters to map and analyze spatial data. For example, a GIS map might show areas of high canopy coverage in dark green and areas with little canopy in lighter colors. These maps can be layered with other information, such as population density, land use, or neighborhood boundaries. This allows city planners and urban foresters to identify areas where additional tree planting would provide the greatest benefit. For instance, a GIS analysis might reveal that neighborhoods with the lowest canopy cover also experience the highest summer temperatures. In response, a city might prioritize tree planting programs in those areas to reduce heat exposure. This type of analysis allows urban forestry programs to move from reactive tree care to strategic canopy management. Instead of simply planting trees wherever space is available, cities can plant trees where they will have the greatest environmental and social impact. In addition to canopy analysis, GIS systems are also used to manage tree inventories, track maintenance schedules, and plan long-term urban forest strategies. Technology has therefore become a central tool in modern urban forestry. For the ISA Urban Forest Professional Exam, remember that aerial imagery, LiDAR, and GIS are commonly used tools for measuring and analyzing urban tree canopy. Questions may focus on understanding the difference between these technologies. Aerial imagery provides visual canopy coverage. LiDAR provides three-dimensional structural data. GIS organizes and analyzes spatial information. Understanding how these technologies work together is important for modern urban forest management. Today we explored how cities measure urban tree canopy using aerial imagery, LiDAR, and GIS mapping technologies. These tools allow urban foresters to analyze tree coverage across entire cities and identify areas where additional trees are needed. But measuring canopy alone does not ensure a healthy urban forest. The types of trees that make up the canopy also matter. In the next episode, we'll explore why species diversity is critical for building resilient urban forests. You've been listening to the Arborist-podcast. Our goal is to grow our collective knowledge, one domain at a time. If you enjoyed the podcast, please like, share, and subscribe to help us keep this momentum. Until next time, let's keep growing this community together.